Very good afternoon. We were discussing about this numericals related to system reliability, and we are discussing about the numericals on that is series configuration. So very two first simple numericals we have discussed, and let us move toward this next numerical. We will discuss one more numerical for series configuration, and then we will go for the next bit, that is parallel configuration. So a system has three components connected in series having the reliability of 0.4, 0.7 and 0.8. See, three components are given. Reliability R1, I can say 0.4, R2, 0.7 and R3, 0.8. Or you can go for any other notation also. So here, for a mission of 400 hours, what is the percentage increase in the reliability of the system in each of the following cases? Percentage increase in reliability of the system. Okay. Reliability of first component is increased by 0.1. That of the second and third component remains same. Reliability of second component increased by 0.1, and first and third remains same. And reliability of the third component is increased by 0.1, and first and second remains same. What is the problem? Try to understand, friends. A system has three components, and it is for first reliability 0.4, second 0.7, third 0.8. There is a mission for 400 hours. What is the percentage increase in reliability for each of the case? So very first, you cannot go directly for calculating the first, means increasing reliability of 0.4 by 5.1, then 0.7 by 0.1 and 0.8 by 0.1. This is the second part. First, friend, we should know what is the reliability of the system now. So 0.4 into 0.7 into 0.8, this we should know that this is reliability for mission of 400 hours. And then if we increase the 0.1 in first, then 0.2 in 0.1 in first, second, and 0.1 in third, by keeping remaining two constant at the three conditions, and then we have to compare it with our standard efficiency or standard reliability which is required for 400 hours. So friends, very first task is to calculate the we can say reliability for 400 hours at the standard condition. Then we will go for condition number 1, 2 and 3. Let us proceed. So very first I will say this, I will say the step number 1. Let us calculate the reliability of the system. Unless and until we are having this reliability, we cannot compare further.
0.224.
Okay, very nice. So I will write Madhoji RES is equal to, I can say R1. No, I will not write all the things, R2, R3. You are getting all these things. So RES, I will say 0.4 into 0.7 into 0.8. So I can say reliability of system is equal to 0.224 mentioned here for a mission of 400 hours.
Okay.
Okay. Any doubt up to this?
No doubt.
Okay, so we have to keep this reliability in mind. We have to compare the other reliability with the system reliability of 0.224. If we increase the component 1 reliability by 0.1, if we increase the component 2 reliability by 0.1, and if we increase the component 3 reliability by 0.1, what is the system reliability changing with respect to this one? This is very important. So I have prepared a table. I will request you to go for preparing the table. So I will solve one, and then I will give 5-minute time to you. See, this table I have prepared. So let us first understand that what is there in this table. though for making the calculations further simple and simple. So reliability of first component, it is given 0.4. Okay, we have said R1. Reliability of second component 0.7. No problem. Now, reliability of third component 0.8. And just now we have calculated the reliability of system is 0.224. Percentage increase in the reliability of the system. We are not applying any of the case. Therefore, here it is dash. Now here we will apply the case number 1, case number 2, and case number 3. So I will mention here case number 1 for the second, case number 2, and then next case number 3. I will give ample time for drawing the table and further things. So just try to concentrate. Now read the first case. What is the first case? Reliability of first component is increased by 0.1, and that for second and third remains same. Second and third remains same. Second 0.7, third 0.8. First by 0.1 means 0.4 it is. So it will become 0.5. So I will highlight here only increase of 0.1 is made. Increase of 0.1 is made. Now I will calculate the reliability of the system. So 0.5 into 0.7 into 0.8. Just one example I will give, and remaining two I will ask you. 0.5 into 0.7 into 0. So this is 0.28. Now percentage increase of the reliability of the system. See friends, now I want to answer that. Previously it was 0.224. Now it is 0.228. How much percent it is increased? So how you will calculate the percentage? So I can say the percentage we can calculate as 0.28 minus 0.224. In comparison of this we are going for, divided by 0.224. Here you will get a fraction, multiplied by 100, you will get a number. So let me know that 0.28. So in comparison with 0.224, how much percent it is increased? Now tell me answer. Something wrong. 79. Okay. 0.28 minus 0.22. It is just near about 0.6 divided by 0.22. So it is coming near about 25%. Will you please calculate once? Hmm, 0.25 Madhoji you are getting, and after that 0.25 multiplied by 100 you will get. Is it okay?
Yes.
Are you getting?
Yes, yes, yes.
Okay, so I will call here as, and a percentage I 25% I will write. Just to it I will highlight. So this is the percentage increase of the reliability. Percentage increase of the reliability. Okay. Now I will highlight second and third cases. I will ask you to solve. Reliability of the second component is increased by 0.1. So now first component is remain constant. What is the value for first component here? Madhoji, second case.
0.4, 0.8, 0.8.
Very nice. 0.4 we will keep at it is 0.8. Here we have increased 0.1 and then 0.8 as it is. And please tell me next case also. Only third component we have to increase, first and second keeping constant. So what will be the values? 0.4,
0.7 and 0.9.
0.9. Very nice. So now I will give you 5 minutes So you
Okay.
please calculate the reliability here. That what is the reliability of the system. For understanding purpose, I am highlighting this. It is not required that you should highlight. So here, take time, and I will directly write now. No detailed calculation. RES is equal to, here you can go for a detailed calculation. Here I will mention RES, and here for your understanding I will say minus 0.224. It is constant, divided by 0.224 into 100. So you will get some value, and here also whatever value you will get, minus 0.224 divided by 0.224 into 100 is equal to, take 5 minutes, calculate slowly, no problem.
Hello.
Yes, Madhavji.
Yes. For second example, the reliability of the system is 0.256. Can you write down in the block diagram of the stability?
Yes, sir. So for second case,
0.256. Multiplication of this 0.4.
yeah, just wait. So second case I will mention here in this screen only. So I will directly write here value 0.256, and then I will take further 0.256 minus whatever. So answer you are getting percentage.
Percentage 14.28.
Okay, very nice. So my answer is 14.29. Okay, so 14.28.
28.
Okay, next.
Next is system reliability is 0.252.
0.252. Very nice. 0.252. And then I will go for 0.252 minus 0.224. What is the answer?
12.5%.
12.5%. Okay. So if I will mention here percentage also. So now what can you say about the inference drawn? So we will go in detail, but where you are getting the maximum percentage increase in the system reliability? First case. Can you draw any conclusion based on this? Why at first case? Okay, so I will say. So before proceeding for the next page, you just try to understand that the improvement in the reliability of system in percentage 25% is higher when what we have done, we have gone for the increment of 0.1 in first component, second component and third component. But it is observed that when we have increase in first component by 0.1, the percentage increase in reliability of the system is more. Now we are discussing why. So here the answer is that based on this, what inference we can draw? So reliability of weakest component is increased by 0.1. See, here the reliability is 0.4. So and here reliabilities are 0.7 and 0.8. So if we take 0.7 to 0.8, it is increased by 14% only. If 0.8 to 0.9, it is observed by 12.5% only. But where is the weakest section, the lowest reliability component? It is part number 1, component number 1. Therefore, if you increase the reliability of the component having the lowest, we can say reliability, or if you increase the component reliability which is weaker, that is 0.4, you have achieved the highest. So in one line you can say, if the reliability of weakest component is increased, then you will get the highest percentage increase in the reliability of the system. Okay, so if anybody want to increase the reliability of a system in series, we are discussing about series. Now don't make it generalized for parallel also. So this is about series. Then if anybody want to increase, then he or she should concentrate on improvement of the poorest component, improvement of the weakest component. If you go for this, definitely you will get the highest increase. And this is the conclusion you will observe in the next slide. Just wait. Inferences. Inference is nothing but what you have learned, what are your observations, what you can comment from whatever the table we have on. So here it is clear cut mention, friends. So here you can see when the improvement in reliability of the system is higher, when the reliability of weakest component is increased by 1. We have said weakest component, it is having 0.4, 0.4 to 0.5. If it is increased, then there is a remarkable improvement in the system is observed. This suggests that if any system engineer want to improve the reliability of the series system, then he should concentrate on improvement of the poorest component, improvement of the weakest component, poorest or weakest component. Then you all of you might have heard a saying that a chain is only as strong as its weakest link. The saying is best fit for series system. So whenever there is a chain, Wow, this is general saying the chain is as strong as its weakest link, because the weakest link fails, the chain will also fail. The unit, it may be component or system, which is poorest in the system from reliability point of view, dictates the reliability of series system. So maximum concentration should be there only for this poorest component, weakest component, and if possible, we increase the reliability of that component. Ultimately, the reliability of this series component, it will be automatically increased. This is about, friends, series. Now let us move further. Let us have introduction about parallel. So in parallel systems, all components must fail for the system to fail. See here. There are 10 components. In series, if any one component fails, the system fails. Let the 9 be working. In parallel, all components must fail for making the system to fail. If 10 are there, 9 fail, then also the system is going on, system is working, system is operational, because that last one is also working. So until and unless all components will not fail, the system will not fail. A parallel system works as any one of the component works. Very, very simple, in simple words. So here, jet engines, then braking system, tires in trucks, projectors, and many examples in the automobile case, and we can go that any one small part of this automobile fails, so it is not having direct impact as far as that automobile and the vehicles are there. So there are some parallel and some series systems also. So it is a complex system of complex, we can say, configuration, which includes the series and parallel configuration also. So parallel system. So a system consists of n independent parallel components. A system fails to function if all n components fail. This we have discussed. So if there are n components, and if anyone desire, or we say that the system is fail, then that all n components should be fail. Again, that nothing, E stands for the component is functioning properly. We have already discussed. E component is functioning properly. I, it may be 1 to 10. So I stands for 1, 2, 3, 4, 5, 6, 8, 9, 10. Whatever the number of components. That I number of components functioning properly. Functioning properly denoted by E. EP, parallel system of n components, is functioning properly. So what is EP? Here it is a system of parallel system of n component functioning properly. Then friends, what is the reliability? As we have discussed in we can say this series. So here also the reliability depends upon the probability of the components will function properly. So here again, as we have discussed in last case, similarly here we can say this reliability is nothing but the probability of all components in parallel system, all n components in parallel system, because if we have discussed, it is the probability of parallel system function of n component is functioning properly. So if these all function properly, and what is the probability of this all function properly is nothing but the reliability of the system for this parallel case. Okay. So again, these are some generalized things. Again, we have to move towards some of the formula. So here you can say the formula is RP in that RS. So for series here RP. Okay, this reliability, you can say system reliability for parallel. So it is 1 minus the product of I is equal to 1 n, I is equal to 1 to n, 1 minus Ri, 1 minus Ri, where Ri stands for the reliability, where Ri stands for the reliability. So let us see that there are R1, I will say R2, and here R3. 3 components are there. So how you can say 1 minus, here you can say it is a product of 1 minus R1, 1 minus R2, 1 minus R3. So this is the product of 1 minus Ri. So product 1 minus R1 is 1. For this case, I am applying the formula 1 minus R2. For this case, I am applying the formula 1 minus R3. For this case, I am applying the formula. And this product of all, so first into second into third, and whatever you will get, 1 minus of this, you will get the system reliability for parallel configuration. System reliability for parallel configuration. Very simple, friends. So this is nothing but the. So let us just wait. Okay. So here I can we can have one example here. This parallel system of independent components follow the product law of unreliabilities. Product law of unreliabilities. Now I will give you one example for this. Okay, so here we will just understand, friends. So here I will say one of the example. Let us have. Okay, so you take, this is one system, one component, second component, like this. I can say this is a parallel system. So now I will say this is my R1, this is my R2. The reliabilities are given 0.9 and 0.9. Okay, take some another number. So I will say 0.9, I will say 0.8. Now how to calculate this system reliability for this? So here it will be 1 minus. I can say summation of I1 to n. So here 1 and 2, R1 and R2. So 1 minus R1, 1 minus R2. So I will say here 1 minus R1, 1 minus R2. So if you substitute the values, 1 minus here, 1 minus 0.9 into 1 minus 0.8. So 0.1 into 0.2. What is the answer for this?
Basic man.
What is the answer? Okay, if you want, again I will go in detail. So 1 minus in bracket 1 minus 0.9, I will say 0.1. 1 minus 0.8, I will say 0.2. So again you have to go it for making minus. So 0.1 into 0.2, and again subtracting it from 1. What answer you will get, friends?
0.98.
0.98. Okay, getting the answer. Okay, very simple. You can, in this way you can proceed further. So if you just have a look toward this, so whatever we have discussed in series and whatever we have discussed in parallel, again there are some formulas. So here we have to use only this formula. that system reliability for parallel is given by this R for parallel is equal to 1 minus this product of I to 1 to n. So 1 minus R1, 2, 3, 4, whatever. And again, you have to go for 1 minus R1, 1 minus R2. The R1, R2 values will be given. And in this way, you have to proceed further. So I want to highlight just one example in order to have some more insights toward this parallel system. Okay, so friends, today we have started for this chapter reliability evaluation of systems, and then we have discussed what is system, what is system reliability, how we should go for this system reliability, and then we can say what is this RBDs we have discussed, that reliability diagrams, block diagram, and it is nothing but a logic diagram representing the arrangement of components. This is the generalized diagram for RBD. It is a combination of series and parallel. And then we have discussed about the more features about RBDs. Then series parallel reliability block diagrams we have discussed. We have started with the series. We have seen in detail the series configuration and its application. Then we have discussed how to calculate the series system reliability, and we have taken this first very simple numerical, then somewhat different numerical, and third this is a typical numerical in which the reliability of the components are changed and its effect on the system reliability is analyzed and we have to predict. So here from this it is commented that for improving the reliability of the series system, one should concentrate on the improvement of reliability of poorest or weakest component. Then friends, we have started with this parallel system. In series, if one component fail, all will fail. Sorry, if one component fail, that all system will stop. Let the 9 or 99 components are working. If there are 100 components, one fail and 99 are working, no use. In series case, all the system will stop. But in parallel case, if 100 are there, up to last, so the system will run. So this is a parallel case. Then we have discussed about the formula, and we have discussed a simple numerical based on this. Thank you.